All right, so what really is the point of all of this? Well, if we know two triangles are congruent, we can get a good chunk of information about them. Um, just by knowing, because if two triangles are congruent, everything about them is the same, literally everything. So with that in mind, there's this thing called corresponding parts. And that's short. Even shorter is Cpctc, maybe. I don't know if that's technically shorter. Cpctc, Cpctc. It stands for corresponding parts of congruent triangles are congruent. Corresponding parts, congruent triangles are congruent. So, kind of three pieces of information here. The corresponding parts. Well, first of all, what are corresponding parts? Now, if I know, let's just talk about things that were given before we talk about like real in-depth stuff. Let's just say that this is triangle ABC and this is triangle XYZ. And if I am told that triangle ABC is congruent to triangle XYZ, I know that angle A corresponds to angle X. Angle A corresponds to angle X. They are in the same position in the names, which is why naming congruent triangles is very important. So angle A and angle X are the first letters, so those are congruent pieces. We know that angle B and angle Y are corresponding because those are in the same position. And we know that angle C and angle Z are going to be the same because they're in the same position. So what does all this mean? It means that angle A and angle X have the same measure. It means that angle B and angle Y have the same measure. And it means that angle C and angle Z have the same measure. So what I was saying before about it's important how you name it, what we could say, if we already know this, I could also say that triangle, let's say CAB is congruent. CAB is congruent to ZXY. It's congruent to triangle ZXY. Now, what I cannot say is that, let's say triangle ABC is congruent to triangle ZXY. I cannot say that triangle ABC is congruent to triangle ZXY because I've already established that A corresponds to X. This is saying that A corresponds to Z, and that's not right because A has one swoop and Z has three swoops. These are different angles. So when you're naming congruent triangles, you have to be very specific about what you are or how you name this triangle. So that's important. So corresponding parts. Now, corresponding parts in congruent triangles are congruent. So A and X are corresponding parts in two congruent triangles. They have to be congruent. That's what Cpctc means. So we can kind of extend this and say that maybe we're given this triangle and we're given this triangle. And in these two triangles, I know that this angle, I know this angle and this angle, and I know this angle and that angle, and I know this side and I know that side. So first of all, the first question I have to ask is, are these triangles congruent? Can we tell? In this case, what we are given is two angles and an excluded side. So I can write this just as sort of helping myself go through this. I have two angles and an excluded side. So this could be written as angle, angle, side, or side, angle, angle. And notice in both, I have two angles and an excluded side. So in both of these instances, angle, there's two angles and an excluded side in both of these triangles. So that's good. I can call it angle, angle, side, or side, angle, angle. Both of these work. These are generally use this one. Both of these are congruence ideas for triangles. So maybe let's change this up a bit. Maybe I'll give myself some more information, like this. Now I have two sides and two angles. However, if it's written like this, these are not congruent anymore because this 2-tick side is off of the 2-swoop angle, and this is only a 1-tick side off of the 2-swoop angle. So these triangles are no longer congruent. These are different sizes. But let's pretend we didn't know that. We don't know this. This is just a regular side, and this only has 1 tick on it. So you have to be careful about the location of the tick marks and the angle markers. So in this case, the 1 tick mark comes off of the 1-swoop angle, and the 1 tick mark comes off of the 1-swoop angle. So this is the same pattern in both triangles. So let's throw some letters on here. This is H, I, J, and P, Q, R. So I'm just going to pick a name for this first triangle, and I'm just going to call it HIJ because, hey, that's the way the letters go. HIJ. And then I want to name, I already know that these two triangles are congruent because of angle, angle, side. So what I want to do now is be able to name the second triangle based off of this first one. The first one can be named anything you want, but once you name the first one, the second one's name has to be written very specifically. So the first one I use here is H. H is 1 swoop, so I have to use the 1 swoop in the first in the second triangle, which is P. Then it goes to the 2 swoop, which is I, because the second one is I, so the I is the 2 swoop. So my next letter is going to be the 2 swoop over here. And my last one is the no swoop, so I use R, PQR. So this HIJ, triangle HIJ is congruent to triangle PQR. This is accurate. If these were in any other order and these were in the same order, this would be incorrect because corresponding parts have to be congruent. So in this one up here where I was pointing at letters referencing the angles, in this case, let's look at sides instead. So in this one, what we can look at is side HI. Side HI is this one right here. And so if this is the first two letters, if I look at the first two letters in this one, I get another side, side PQ. HI corresponds to PQ. So HI has to have the same measure as PQ. So in another one, let's look at another one. Let's say that we look at IJ, side IJ. IJ corresponds to QR because IJ is the last two letters and QR is also the last two letters. So in this one, segment IJ has to be congruent to segment QR. And there's one more that if we look at the first and last letters, and I'm going to kind of write above them, that these two, segment HJ and segment PR, those are also congruent or corresponding. But if they're corresponding, they're also congruent because corresponding parts of congruent triangles are congruent, Cpctc. That being said, I know that looking at this, I know that angle H is the same as angle P. It's the same measure. Angle H is congruent to angle P. Angle I is congruent to angle Q. Angle J is congruent to angle R. Side HI is congruent to side PQ. Side IJ is congruent to side QR. And side HJ is congruent to side PR. And those are the 6 congruent parts in these two congruent triangles. So how does that help us? Well, let's just use these. Let's say that I'm looking at this and I see, and I am told that this side is X, this side is 3X, this side is, let's just make it easy, this side is 12, and this side is Y. And I also need to know something else. Let's call this side 9. So if I want to figure out what X and Y are, what I can do is I can look at ij. Well, ij corresponds to side QR. So QR is 9. So I know that ij also has to be 9 units long. Now, if I say the two sides are congruent, what I mean is that their lengths are equal. So if I know the length of side ij is 3x, 3x has to be equal to 9 because segment ij is congruent to segment QR. Segment QR. Now, knowing this, changing this into equality, I know that the length of ij, which is just denoted with an I and a j, is going to be equal to QR, which is the length of segment QR. This is geometry notation, that if I have segment ij is congruent to segment QR, then ij, which means the distance between I and j, is equal to QR, which is the distance between Q and R. Now, what I know is that ij is 3x and QR is 9, so I know that 3x has to equal 9, which, a little bit of algebra, if I divide both sides by 3, I get that x is 3. So if x is 3, this side is 9, which is accurate because that corresponds to this side, and if the x is 3, this side is also 3. Now, if this side is 3, I know that hi, segment hi, corresponds and is congruent to segment hi is corresponding and congruent to PQ, segment PQ. And doing that, I know that the distance between h and I has to be equal to the distance between P and Q. The distance between h and I is x. The distance between P and Q is y, so those have to be equal. Well, I know x is 3, so y has to equal 3. And I get all of this just by knowing that this piece is congruent to that piece because they are corresponding parts in congruent triangles. There's one last piece of information that I don't even have marked, but I know that PR corresponds to HJ, so HJ also has to be 12. And that's the whole idea behind corresponding parts of congruent triangles. Now, one thing that I didn't actually go over in the isosceles triangle video is that well, I didn't go over it directly, but let's quick review. If I have an isosceles triangle and I bisect the vertex angle, so I bisect this so that this angle is congruent to that angle, it bisects the opposite side at a right angle. Now, right now, what we have, if this was an isosceles triangle, that's what we're given. If we bisect this isosceles triangle, it bisects this side. If I do that, I have a hypotenuse and a leg of two right triangles, because if this is a right angle, that's also a right angle. I have a hypotenuse and a leg of two right triangles. This isosceles triangle got split in half. And actually, I can say that specifically that this was split in half. Because if this was isosceles triangle MNOP, well, let's say the P is the midpoint of side MO. If MNO was an isosceles triangle, this angle bisector actually splits it into two congruent triangles. Triangle MNP. And now, if I want to write the triangle that it is congruent to, I have to look at, I have to be very careful about how I name this. MNP goes through two ticks and then the adjacent side. Or not the adjacent side, the shared side. NP is a side that is shared between both triangles. So if I want to name the other triangle has to be named ONP because as I'm naming this, it goes through two ticks and then this shared side. So triangle MNP has to be congruent to triangle ONP, which gives me a whole lot of information. If I have an isosceles triangle that gets bisected, and I know this is 13, this also has to be 13, and if I knew that this whole side was like 18, not drawn to scale, and this angle was bisected, that tells me that this piece has to be 9 and this piece has to be 9. It has to be. That's how it works. Also with isosceles triangles, if I knew, let's say that I know that this angle right in here, the angle that was, the piece of the angle that was bisected, maybe that's 30 degrees. Maybe it's 35 degrees. Let's make it 35 degrees. If this angle is 35 degrees, there's a couple ways that I can find these two base angles. One of them is I know this got split into a right triangle. So that means this 35 and this 90 and this angle all have to add up to be 180 degrees. So one way I can write that is 35 plus 90 plus some angle that I don't know has to equal 180 degrees, because no matter what, all angles in a triangle add up to be 180 degrees, as long as you're drawing on a flat surface. So 35 and 90 is 125. So 125 plus x has to be 180. Now if I subtract 125 from both sides, I am left with x equaling 55 degrees. So this base angle has to be 55 degrees. Now, knowing that, since this was an isosceles triangle, I also know that this other side has to be 55 degrees. But let's find this angle in a different way. Since this half of the vertex angle is 35 degrees, the whole vertex angle has to be 70 degrees. So if I know that this vertex angle is 70 degrees, how am I supposed to find the base angles? Well, what I can do, I know that the base angles have to be congruent. So this x and this x have to be the same thing. So knowing what I know about triangles, I can take 70 plus x has to equal 180 degrees. So I can add these x's together and get 70 plus 2x equals 180 degrees. And I can subtract 70 from both sides. If I subtract 70 from both sides, I get that 2x equals 110. And if I divide both sides by 2, I get that x equals 55. It's the same answer. Math works multiple ways. There are different ways to get the answer. So I also can find out that this angle is 55 degrees using a completely different method, but it still works out. And I think that's really all I want to talk about involving Cpctc. Super important.